Okay, so we're continuing with Chapter 3, and we've been talking about vectors, and now we're going to talk about projectile motion. And projectile motion is really important in physics. And so this is going to be based on video BMAPhysics 3H, okay, and that is that's a football pass. Okay, so what we're going to do is we head out on the field. We had one student throw a football to another student, and I just sort of took some rough measurements. And basically what I figured out was that the ball was in the air about 78 frames of the video. And so if I divide that by 30 frames per second, I am going to end up with 2.6 seconds. And distance downfield I'm going to call it approximately 26 meters. And that's just sort of an estimate that I did based off of kind of measuring people on the field, assuming that they're about 6 feet tall, and kind of measuring the horizontal distance and seeing where we go from there. Okay, so now we're talking about projectile motion. And we're going to be in 2 dimensions. Okay, so the 2 dimensions we're going to have is we're going to have a horizontal dimension and we're going to have a vertical dimension. And they're going to have their own separate charts. So the key thing is that they're going to have their own separate charts. X, T, V, I, V, F, A, and X, T, V, I, V, F, A. Okay, now we said that the horizontal distance that it traveled was about 26 meters. And we said that the time that is spent in the air was about 2.6 meters, or I'm sorry, seconds. 2.6 seconds. Now, that time, the time that is spent traveling horizontally is going to be the same as the time it's spent traveling vertically. So I can put that over there as well. Okay. Now, a couple of things. There's 3 things we can fill in just off of things we know. Now, the ball travels in a parabola, something like this. And so the ball goes up, and then the ball comes down, and if you think about it, so this distance here, that's 26 meters. But the thing is, what's the vertical distance between these 2 dots? The vertical distance between those 2 dots is nothing. So it goes up from the field, it comes back down to the field, and so the total vertical distance that it travels is 0 meters. Okay, now we know something about the accelerations too. By this time you should know that the vertical acceleration is negative 9.81 meters per second squared from previous considerations. We talked about that in chapter 2. Now, gravity is pulling it in this direction. Once it is in the air, once the ball has left the thrower's hand and before it hits the catcher's hand, the only horizontal force on it is going to be wind resistance. And we don't care about wind resistance. We're just going to say wind resistance doesn't exist, and so since wind resistance doesn't exist and it's the only horizontal force, we're going to say the horizontal acceleration is 0 meters per second squared. Okay, so now I can fill in. What I'm going to fill in right now is I'm going to fill in this, and I'm going to fill in that. Okay, so this is pretty easy, and the horizontal is not so bad. I have x equals VIT plus 1/2 AT squared, but my A is 0. And to find VIT, I get VI equals x over t. So I have VI is equal to 26 meters divided by 2.6 seconds is equal to 10 meters per second. Okay, now vertical, we're going to say x equals VIT plus 1/2 AT squared. And now in this case, that's equal to 0. For this example, and so that allows me to do some switching around. Negative VIT equals 1/2 AT squared. I can divide by a negative t, and I can get negative 1/2 AT. So my VI is going to equal to negative 1/2 negative 9.81 meters per second squared, and 2.6. Okay, so that's going to give me 12.8 meters per second. Okay. Now, the last thing that I'm going to do in the next 90 seconds here is I'm going to put those into a triangle, and it's going to get a little bit busy over here, but we're going to make a triangle right here. And the vertical leg of my triangle is 12.8 meters per second. The horizontal leg of my triangle is 10 meters per second. Now by Pythagorean theorem, I'm going to go through this fast because I have 1 minute. By Pythagorean theorem, I'm going to get 12.8 squared plus 10 squared. That's going to be 16.24, so call it 16.2 meters per second. And then I'm going to use an inverse tangent, so I'm going to do shift tan 12.8 divided by 10. I'm going to get 52 degrees. So, what I have just determined from that video and my estimates is that the thrower of that football threw the football at 16.2 meters per second at an angle of 52 degrees above the horizontal. And that concludes that example problem.